different ways to arrange a certain number of objects in a given set. So here's the situation. 4 boys and 5 girls are forming a line. Find the number of possibilities for each type of line described below. So just in total, how many different ways can this be done in number 1? How many different ways can these boys and girls form a line? How many people total? 9. Let's start diagramming it out. How many different people could be in the first place in line? 9. And how many after that? Second place would be how many other people? 8. Then 7, 6, 5, 4, 3, 2, and 1. So you could type that all in, or what other notation is available to us? Yeah, the factorial. So about 362,880. Reading that from my calculator. Kind of a slick way to type in 9 times 8 times 7 all the way down to 1. This is really just 9 factorial. Or, that was once again, 362,880. So if there are no restrictions on how I want these boys and girls to line up, there are 362,880 different ways to do it. There are that many number of ways to arrange 9 objects in order. Okay, now let's look at another type of line. I want the first 2 in line to be girls. How many lines are possible if the first 2 in line are girls? So let's start diagramming it out again. I want a girl and a girl to come first. After that, it doesn't matter. How many different girls could I pick to put in first? 5. How about after that? 4, because I've already picked 1 girl, so there's only 4 girls left to pick from to put in second place in line. Now it doesn't matter. How many people are left? 7. So there are 7 people to pick from for the third place in line, and then on down from there. 5, 4, 3, 2, 1. This part of my sequence is really what 7 factorial. It's 5 times 4 times 7 factorial, or 20 times 7 factorial. $100,800. Option number 3, how about the number of lines possible where the first person in line is a boy and the last person in line is a girl? I need a boy to come first, a girl to come second. After that, it will not matter. How many different boys could I select from to put in the first place in line? There are 4 boys to choose from first. Let's start with what I have to have placed first. What's been given to me, and then everything else should kind of fall in line from there. How about the girls for last place? How many girls are there? 5. How many people are left? 7. So the middle should just be the same 7 factorial. I believe this is the same as was in the previous question. The middle part, 7, 6, 5, 4, 3, 2, 1, is 7 factorial, with the 5 and 4 multiplying to make 20 after that. So that would be the same 100,800. last couple here to the side on the right. How many lines are possible where the boys are together? Let's start putting this out. I want to arrange the line so that the boys are always together and the girls are around. So let's start with this. I'll put all the boys first. There are 4 boys. Let's do boy, 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 girl, 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 girl. How many boys are there? There should be 4 boys. So it's 4, 3, 2, 1 times 5. 4, 3, 2, 1. All the boys are in the first positions in line. All the girls follow at the end. How else could I arrange the line? Because that's not the only line that's possible. All I need to do is group the boys together. So how else could I place them in line? At the end, sure. How about in the middle too? Couldn't I have girls on either side of the boys? So let's start by diagramming out more different lines. What if I have a girl come first, followed by the 4 boys, followed by the rest of the girls? I'm just going to slide the boys from the front all the way to the back. There were 4, 3, 2, 1, and then 5, 4, 3, 2. How many different lines are going to be possible if I just keep sliding the boys from front to back? Now I can have girl, girl, boy, 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 girl, girl, girl. I'll put 2 girls in front of the set of boys. 4, 3, 2, 1, 5, 4, 3, 2, 1. How many different lines are going to be possible? You could write them all out, but maybe let's take a shortcut here. How many more different lines could I write?
2.
3, right? Because it's going to take me 3 more lines to go from this boy all the way to the very end. So how many lines are in total?
6.
There's 6 total lines where I have all the boys grouped together. There are 6 ways to have all the girls be around the cluster of boys, right? So I could have the boys from anywhere all in front to all in back. No matter how I do it, what am I always going to have? Well, I'm going to have 4 factorial times 5 factorial. 4 factorial times 5 factorial. 4 factorial times 5 factorial. So each line has the same number of permutations. There's 6 total lines possible times 5 factorial and 4 factorial. The first 6 tells you how many lines are possible. The 2 factorials tell you how many different ways there are to arrange the boys and girls in each of those 6 lines. Does that sound right?
How do we know it's 6 without counting them out?
There are 5 girls. It's always one more than that. So that got me to 17,280 different lines. There's gonna be 6 lines in total, because I'm moving the girls around the boys.
Dylan Coffin, please report to the secondary office. Dylan Coffin, report to the secondary office.
I'm basically breaking up the 6 into 6 different ways, right? I'm breaking up the 6 girls into 6 different clusters.
Yeah.
Either all at the end, 1 at the front, 5 at the end, 2 at the front, 3 at the end. So there's going to be 6 different ways to have that done. Let's see, the last type of line I want to set up. The lines where no girls are together. No girls are together. If no girls are together, that means that the girls have to alternate. Girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, right?
Yeah.
So what do I have to start with, a girl or a boy? A girl. There's more girls than boys, so shouldn't I have to start with a girl when I set up my line? So if I diagram this out, it's got to go girl, boy, girl, boy, girl, boy, girl, boy, girl. Now I've got all 6 girls and all 5 girls, all 4 boys. 5 girls and 4 boys. So 5 girls, 4 girls, 3 girls, 2 girl, 1 girl. Do the boys next. 4 boys, 3 boys, 2 boys, 1 boy. 5 times 4 times 4 times 3 times 3 times 2 times 2 times 1 times 1. Using factorial notation, what would that be the same as? Sure. 5 factorial. 5, 4, 3, 2, 1. There's 5 factorial. 5 factorial for all the girls, and 4 factorial for all the boys. So 2,880 different ways to have the line set up where there's no girls together. In other words, the boys and girls are alternating.